Discover the unparalleled beauty of Kanab, Utah, the heart of the parks, and the ultimate base camp for your national park adventures. Kanab, Utah offers easy access to not one, not two, but three of America's most iconic national parks. Explore the majestic Grand Canyon, hike the stunning trails of Zion, and witness the awe-inspiring landscapes of Bryce Canyon. All just a stone's throw away from Kanab. But Kanab is more than just a gateway. Locals call it the Little Hollywood. It's a charming town with a vibrant community. So whether you're an outdoor enthusiast, a nature lover, or a curious traveler, Kanab welcomes you to make unforgettable memories in the heart of the parks. Plan your journey to Kanab today at visitkanabutah.com. Your gateway to endless adventures starts here.
Today's show is brought to you by ExpressVPN. Protect your online activity today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello once again. Thank you for joining us. This is the podcast we call Space Nuts. We talk about astronomy and other things. My name's Andrew Dunkley, and joining me as always is astronomer from the Australian Astronomical Observatory, Fred Watson. Hello, Fred.
Hello, Andrew.
How are you, sir?
Yeah, well, I'm well. I hope you are as well. I hope you're keeping all your illnesses under control.
To quote an old friend of mine, any fitter I'd be up and about.
Yeah, well, there you go. Doesn't get any better than that.
Absolutely. Now, in this episode, we're going to talk about former US astronaut Alan Bean. He passed away a couple of weeks ago, but what an amazing life. And we're going to talk about some of his career achievements. We're also going to look at lunar eclipses and climate change, two things you don't normally put together. And a question about the TESS mission, which we talked about a few weeks ago. Somebody's got some thoughts on looking for exoplanets, and a couple of questions have popped up as a result of that. So we will endeavour to answer those questions for our avid listener. But first, Fred, let's look at the life and times of astronaut Alan Bean.
Yeah, that's right. A sad story, Andrew, and I guess one that we comment on fairly regularly when those great heroes of the Apollo era, all those years ago, 50 years ago next year, Apollo 11, those great heroes gradually fade away and pass away. So today we're celebrating the life of Alan Bean, who was actually the fourth man to walk on the moon. He was an astronaut on the Apollo 12 mission, so only the second lunar landing mission, and actually a particularly special one because he and his co-pilot for the lunar module, Pete Conrad, they landed the lunar module within walking distance of a spacecraft called Surveyor 3, I think it was.
Yep.
Which had landed on the moon about 18 months earlier. And it was Bean and Conrad who famously removed a TV camera from the Surveyor lander and brought it back to Earth, whereupon it was discovered to have microbes on it, which has been controversial ever since.
Yes.
Whether the microbes survived 18 months or whatever it was on the moon's surface or not. Really interesting stuff. That would need a whole Space Nuts session to discuss that because there's a lot to say about it. But anyway, Alan Bean was one of the conspirators in that venture. Of course, it wasn't a conspiracy. It was all planned by NASA that they should land next to the Surveyor lander just to see what the effect of those many months on the lunar surface was for a piece of hardware like that.
Yeah, and he was quite young when he walked on the moon. I'm just trying to work it out in my head, but he was probably only in his late 30s, which for an astronaut of that era was quite young.
Yeah, they were. Most of those guys were in their 30s. That's right. And you know, I was just flicking through some of the news reports of the sort of the asteroid, sorry, not the asteroids, the astronauts, and where they are today. And you see all these photographs of young men in their spacesuits, you know, full of energy and full of life, and
their crew cuts and their
yeah, that's right, all ready to go. And here they are, like we all do, rather more aged, I suppose is the word.
Yes,
so Alan Bean. Very interesting life, because he did fly again. If I remember rightly, he was on the Skylab. So back in 1973, which is kind of 4 years after his Apollo flight, he was the commander of the second crewed flight to Skylab, the very first space station. So yes, two really successful missions. And then 8 years after that, in 1981, he retired from NASA and became an artist. And that, I think, is fairly unusual among the retired astronaut corps. I don't know that any of the others became artists, but I might be wrong there. But he made actually a significant career as an artist. And he you know, what he did was combined his love of space and his interest in space with his love of art, and essentially has a very large portfolio of space-related of images that he's painted. They're pretty good too.
It might have been a way of escaping the hyperbole of being an astronaut and being a pioneer in some of the great achievements of humanity, because for some, it was really stressful stuff. I mean, Buzz Aldrin went through a terrible, terrible time personally after Apollo 11. He really suffered. Thankfully, he came through it, but he still deals with it today, and he's certainly had issues with people making terrible accusations about the moon landings being fake, and he was a target of that. I mean, it wouldn't have been an easy life coming back from such an extraordinary thing and then trying to get your feet back on the ground. Literally.
I think that's right. And, you know, I guess we've all seen some of the stories, as you've mentioned, of the stresses that the astronauts went through. One of a little footnote to this story, Andrew, is that as we stand now, only 4 of the astronauts who walked on the moon are still alive. And they're Charlie Duke, David Scott, Harrison Schmitt, of course, the famous astronaut from Apollo 17, and of course, the most famous of all, Buzz Aldrin. Still going strong.
I still remember the day I met him. He turned up out at an aerodrome not far from where I live now, and he was here for a dedication to flight, because they built a replica of the original Wright Flyer. Out at Narromine Airport, and if anyone wants to look it up online, they can see what they did. It's a beautiful replica. It actually flew that day, and Buzz was there to witness it and to address the crowd. Thousands of people turned up to hear him speak, and he wore a tie with little moons on it. And you know, he, even all these years later, he still obviously is very connected to what he achieved and what he did in the 1960s. So amazing man, and you can say the same of all of them, because you know, they talk about them having the right stuff, and they certainly had to have that. And Alan Bean certainly did, and he lived a very good life, and he died at a ripe old age, 86. That's not a bad innings, to use the Australian vernacular.
No, so R.I.P. Alan Bean, another milestone in the history of space travel.
You're listening to Space Nuts. Andrew Dunkley here with Fred Watson. Now let's take a little break and find out more about our sponsor, ExpressVPN, rated #1 by TechRadar. This is the one I use. I've been using it for a couple of years, and I love it. When I joined ExpressVPN, they were brand new to the market, but I read a lot of reviews and did a lot of comparisons. And there was just something about their business model that I particularly liked. And a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree. And governments are getting more and more interested in what you're doing every day. And so, yeah, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
And now we're going to turn our attention to 2 things that you'd not normally put together, lunar eclipses and climate change. But apparently there's a lot to learn about climate change from a lunar eclipse. How so, Fred?
It's because when you see an eclipse of the moon, what's happening is the moon is passing through the Earth's shadow, and there's actually one coming up this year, which is one of the, will be one of the deepest eclipses. By that I mean the moon goes right through the middle of the Earth's shadow, so it's a long eclipse. Mm-hmm. But the moon is not completely dark, and the reason for that is that the Earth's atmosphere basically scatters light. And scatters the light of the sun into the shadow of the Earth. And so when the moon is deep in the Earth's shadow, there's still that scattered light there. And of course, it is red. We all know that when you've got a total eclipse of the moon turns into this blood red colour.
Yes.
And that's because the light is preferentially scattered in the shorter wavelengths. To use the technical term, that means blue light. Blue light scattered out and actually becomes the blue of the sky. The red light more or less continues, although it's still scattered, and falls on the disk of the moon. So you've got this amazing red coloured moon. It looks bizarre. There was an eclipse earlier this year, and I was up at Siding Spring, and there was this strange red object in the sky. It was really quite remarkable, a bit spooky, actually. You can understand why all kinds of mythology would spring up around those eclipses. Just to put it another way, and I always think this is a great way of thinking of it, if you were standing on the moon, on the Earth-facing side of the moon, when an eclipse like that was taking place, what you would see would be the Earth itself, but it would be basically a brilliant ring of light, red light, which is the atmosphere showing up. There would be, darkness in the middle of the Earth and this brilliant ring of red light around the edges of it. And that's where the redness comes from. And it would be quite spectacular. It would be very, very intense, as witnessed by the fact that the moon reflects so much back of it to us here on Earth.
Yeah.
So that's the background. But the interesting thing is what you can learn by looking at the actual colour of this red illumination, because the scattering of the red light, it depends, the extent of the scattering depends on how much dust and aerosol material there is in the Earth's atmosphere.
Oh, okay. And so we're talking about how dirty we are at any given time.
Exactly. If the atmosphere is dirty, then you're going to get different sorts of colours and different scattering from if the atmosphere is clean,
Right.
clear.
Okay, well, that makes sense.
It does. And what makes the atmosphere dirty? Well, in particular, it's actually volcanic eruptions. The amount of material that is high in the atmosphere, particularly dusty material, but aerosols as well, droplets of liquid, that it is dictated to a large extent by the amount of volcanic material that has spread up into the atmosphere. Now, volcanoes are going off all the time in the Earth's atmosphere. So
although this year seems to have been a particularly busy one in terms of volcanic activity. Right. We've had, not just on Hawaii, but we've had volcanoes doing their stuff all around the Ring of Fire, all around the Pacific Rim. So yeah, this could be a really fascinating eclipse later this year.
It could be, that's right. It could be interesting to see what it's like. Anyway, the reason why this is in the news is that at a recent conference, an emeritus professor, Richard Keene, who's at the University of Colorado in the USA, he basically prepared a paper. It's in the form of a poster. That's often the way we present things at these conferences, as a poster paper. His poster is called Volcanic Aerosol Optical Depths During the Post-Pinatubo Era 1996 to 2018, which doesn't sound terribly exciting, but what he's saying is that he studied eclipses over the period since 1996. We're talking about rather more than 20 years. I think he's based in Maui. I certainly observed from there, a favourite place of both you and me, Andrew.
Yes, indeed.
And he studied the intensity of the eclipse and the intensity of the colours. And what that lets him do is calculate what we in the trade call optical depth, which is how far you can see through something. That's the way, basically what it means. That the greater the optical depth, the more transparent something is. So he's worked out what the optical depth of the atmosphere is and demonstrates that since the Pinatubo eruption 20-odd years ago, the atmosphere has got much cleaner. It's as you'd expect, the dust eventually falls out of the atmosphere, the ash and the gas that turns into aerosols, and falls out of the atmosphere, and so the atmosphere gradually improves. But what his corollary to this is the really interesting bit. And what he says is, compared to the murky decades of the Pinatubo eruption and others that he was looking at, the clear stratosphere since 1995 has allowed the intensity of sunlight reaching the ground to increase by about 0.6 watts per square meter, which is equivalent to a warming of 1 or 2 tenths of a degree Celsius. That's 0.1 to 0.2 degrees Celsius. In other words, he adds, over the past 40 years, the decrease of volcanic aerosols and the increase of greenhouse gases have contributed equally to the total warming, which is about 1/3 of a degree, observed in global satellite temperature records.
Isn't that amazing?
This is a really interesting little attribute of the warming that we're seeing, that you can attribute half of it to a clarity of the atmosphere, which we didn't know about before.
Yeah, well, that's going to get a lot of people arguing then, isn't it? Because they'll say, look, it's not all our fault. Some of it's natural.
Spanner in the works, exactly. Of that kind, yeah.
But that doesn't change the fact that the temperature is rising and we're putting a lot of extra carbon into the atmosphere. But as you said, there's an eclipse this year, and it'll be interesting to see how the analysis works in that one, given that it's been quite active volcanically on the planet over the last 6 months or so, and that continues as we speak. But when you look at the photographs of the eclipses, 1992 to now, you can certainly see a difference. 1990, that Pinatubo volcanic eruption, one single volcano made such a difference to the world. And it was a huge explosion. I've seen footage of it and photographs, and it was one cataclysmic event in the local area. Incredible. And there's been a couple since then, of course. There's the one in Indonesia that stopped all air traffic there for quite some time. And there's been a few others like that.
Not to mention Eyjafjallajökull.
Yeah, that one.
The Icelandic volcano, which stopped air traffic, including my flight back to Australia.
Yes,
in 2010. But yes, that's right. But I think Pinatubo was, an order of magnitude bigger than these ones.
Yeah, it's been the biggest one in decades. No doubt about it.
Yeah.
Huge. So anyway, that's all cleared itself up, and of course this all creates a layer, doesn't it? And when it settles down, and in time, they can sort of find that eruption again in the archives, in the earthen records.
Yes, that's right.
Yeah, it's fascinating.
Indeed, that's right.
All right. So we'll keep. When is that eclipse, by the way?
27th of July.
Okay. Well, we'll
I
keep
need
an
to
eye
check
on that one.
where it's visible, but 27th of July this year.
Love eclipses. Don't know why. They're just so fascinating. You're listening to Space Nuts with Andrew Dunkley and Fred Watson.
3, 2, 1.
Space Nuts.
Finally, Fred, we're going to answer a question from our studio audience. And this one is sort of come up in regard to something we discussed recently, which is the TESS mission. So I'll just read the question, and then by the time I've finished, we'll be starting next week's episode. This comes from Alex Simmons in Bellingen in New South Wales. I very much enjoy listening to the show each week. Keep it up. I'd not heard the show before it became a podcast. Yeah, well, it's because it was on local radio. It wasn't very widespread. We had an audience of 2 dogs, a cat and a budgie. I have a question about a topic you covered some weeks back, TESS, the Planned Exoplanet Search Mission. In the show you mentioned the TESS spacecraft will sweep a large majority of the sky looking for exoplanets using the transit method and cover far more sky than the Kepler mission did. Given TESS is a 2-year mission and the time spent collecting starlight data on any one segment of the sky is limited to about 4 weeks total. Presumably this means it can only confirm short-period exoplanets. By confirm, I mean the multiple observations of the same exoplanet transit. Is this correct? What would longer-period exoplanets, or what about longer-period exoplanets? How do we find these? Or is TESS simply pointing out good candidates for other observation methods? I kind of figure longer period exoplanets are more likely not to be tidally locked and perhaps maybe better candidates for signs of life if in the habitable orbit zone. Many thanks, Alex. And now I need oxygen.
Alex, your question is right on the money. It's a great question. I know it's there's several components to it. But everything that Alex says is correct there, that, there are relatively limited amounts of time that TESS will be looking at individual stars. So just to backtrack slightly, Andrew, the idea of TESS is that it will look at patches of sky and monitor them for dips in the brightness of the stars within them. And it's going to look at millions of stars. It's a very big project compared with its predecessor, Kepler, which only looked at one particular chunk of sky. TESS is going to survey the whole sky. But exactly as Alex says, the dips in the brightness of these stars, which reveal the presence of a planet passing in front of the star, when you've only got a limited amount of time, what you can't do is what you need to do to confirm that these planets are real, and that is to look at many transits of the same planet. So by that I mean, if you watch the star for long enough, you'll see the planet pass in front of the star as it orbits around the star. For example, if you were doing this from a great distance and looking at the solar system and looking back at the Earth, you'd see the Earth transit across the sun, and then a year later it would do it again, and then a year after that it would do it again. So these are what we call long period planets, because they're planets like the Earth, which are relatively lengthy in their time span around the orbit. In fact, we regard that as normal. A year to us is a normal length of time.
Sure.
In many of the exoplanets that have been discovered, many of them are around dwarf stars, much smaller stars than the Sun. So they orbit closer to their parent star, and that means that the transits are more frequent.
Like a strobe light.
Well, not quite as frequent as that. Some of them are a bit wild when you've got an orbital period of a day and a half or something like that. But so the point that Alex makes is very valid. That if you've got sort of 4 weeks or so of total data on any one bit of the sky, which is about right. So I think it's 27 days or something. With the exception, actually, just let me mention that near the ecliptic poles, which means the direction right angles to the Earth's orbit, the coverage is much more complete there. You've got much longer periods of time because this thing's scanning the sky in a polar way, so it crosses the pole lots and lots of different times. But for a normal bit of sky, yes, it's roughly 4 weeks. And so what you are going to rely on to actually characterize these planets and work out what their orbits are, you're going to have to rely on multiple observations, and by that I mean follow-up observations with different ways of carrying it out. So what TESS will do is find the single transits. That's what it will be best at, and it'll flag those, and it'll do that very, very well. And then a battery of actually Earth-based telescopes, which are pretty capable of doing the follow-up work, they will follow up on these so that we will know what the orbital period is of these individual planets. There will be some that TESS can characterize straight away, the ones with periods of 10 days or 20 days or whatever. But for the longer period ones, it will rely on follow-up observations. And actually, the best follow-up observations include huge telescopes taking spectroscopic observations. That means breaking the light up into its rainbow colors and looking for the velocity changes in the star, which reveals the presence of a planet round it. That's the best way to characterize it. Alex's question, what about longer period exoplanets? How do we find those? Well, we do it by follow-up. And Alex actually says that, or is TESS simply pointing out good candidates for other observation methods? That's the bottom line. There will be some that it will be able to characterize, as I said, because of multiple transits, but most will be, here's a transit. We can recognize a transit, by the way, by the shape of what we call the light curve. It's the way the light dims. It has a very specific pattern to it. And so that tells you that you're not just seeing the star feeling like it needs to give out a bit less light. You're actually seeing a transit. His final question is right as well. I kind of figure longer period exoplanets are more likely not to be tidally locked and perhaps maybe better candidates for signs of life. So what that means is if you've got a planet orbiting its parent star close in, it's very likely that one side of the planet will always face its parent star, a bit like Mercury does. Yeah. And that tends to mean that one side of the planet is going to be very hot, the other side is going to be very cold. Life might not take hold there, although some people have suggested that even in a planet like that, there will be a zone which is kind of on the border between light and dark, what we call the terminator, that division between the light and dark side of a planet, which is always going to be in the same place as far as the inhabitants are concerned. That might be a place where life could kick off. But that's a bit speculative. Great stuff. TESS will discover longer period planets, but the determination of the period will be with follow-up observations. It's going to be very exciting. I think they're still going through the system checks and things of that sort before the spacecraft starts sending back data. It is already in orbit, but we'll see what's happening. It's a very exciting project.
But the truth of the matter is it won't find everything. There are going to be gaps in the knowledge. We can't possibly find every planet orbiting every star in all of the sky that it'll be watching. There'll be stuff left for later, is what I'm saying.
There will. And of course, that's a very important point in this particular case, Andrew, because the only ones that TESS will find are stars that orbit their planets in a plane that actually intersects the Earth.
Yeah.
It's got to be the right orientation. There's going to be many planetary systems where there's no transits at all because of the planetary systems tilted with respect to the line of sight to the Earth.
So if we were to try this from, Mars, would that make any difference at all? Or would we have to go to another galaxy or another?
Yeah, well, actually, probably to another star. That's right, to make a big difference. Yeah, but the statistics are still in your favour. I think you still get something like 10% of all, of all the planets around other stars, even with that limitation that you can only see the ones that actually pass in front of it. Mm-hmm. Of course, the nearer the planet is to its parent star, the more likely you are to see it. And that's just because of the geometry.
Yes. It would be really fascinating. Look, who knows how many planets it will detect, but it will probably be a lot.
Yep.
That will give us a lot of information, and it just adds more and more to the likelihood that there are going to be Goldilocks planets. There's going to be liquid water on some of these, and who knows what that means, down the track. We can do spectrum analysis and say, okay, well, there's a lot of junk in the sky. They've got a global warming problem.
We will.
Yeah.
We will. And, the next generation of big telescopes is going to be pivotal in doing those observations. It's going to be very exciting.
Indeed. All right. Thank you for your question, Alex. I hope we answered it adequately. I know I did. And that's it from us for this week. Thank you, Fred.
It's always a pleasure, Andrew. So always a pleasure helping you answer the questions.
Yes, it is indeed. We'll see you next time. Fred Watson from the Australian Astronomical Observatory, and from me, Andrew Dunkley. Thank you for listening. Don't forget to tell your friends and keep sending us all your photos and your information and, of course, your questions. We love those. And we'll see you next time on Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast. Subscribe to the full podcast on iTunes, Audio Boom and Stitcher, or your favourite podcast distributor. This has been another quality podcast production from Bitesz.com.